Okay, so for this lesson, we are going to identify similar right triangles. Two right triangles are considered similar. That is a mathematical word. I know that seems weird, but similar is used as a mathematical word. They're considered similar if their corresponding leg lengths are proportional, meaning it could be a simplified fraction of itself. So let's look at these. We have two right triangles. This leg is similar to this leg, so they colored it the same color. This leg is similar to this leg. And this leg is similar to this leg. What that means is if I were to write each one of these as a fraction, they would all reduce to the same number. Does that make sense? Okay, so let's do one of these. Example 1. So we have our two triangles, and we are going to tell whether the two triangles are similar and explain our reasoning. I don't know that I care about explaining it. Okay? Just looking at these, do they look similar?
Yes.
Yeah. My picture looks a little wonky because it's bending right there in the page. But in your actual textbook, they do look similar. But that doesn't necessarily mean they are similar. When you have two triangles and you're trying to decide if they're similar, always rotate the triangle so that they look the same. You see how they're both facing the same way here?
Yep.
Always rotate it so that way it's easy to find your corresponding lengths. So in this case, the bottom is corresponding to the bottom on both of those, right? So I can write 12 over 8 and reduce that. Reduce it and I would get what? Stop. I know you're not listening if you're over there giggling, people. Divide both of these by what? 4?
Mm-hmm.
So I get 3 over 2. Right?
Yep.
So now let's do this one. We have this length and this length. Whichever length you put on top for the first one, you do the same for the second. So I'm going to do 7.5 on top over 5 on the bottom. And then reduce that.
Can you reduce 7.5?
Yeah.
How does the girl laugh?
No, he was choking on his chip. Okay. You can divide both of these by 2.5. 7.5 divided by 2.5 is 3. 5 divided by 2.5 is 2.
So you can't put the straight out 4 in there? It'd be like 4 divided by something.
Where would the 4 come from?
No, you know, the 12 over 8, you know, thing.
Oh, yeah, you could say divided by 4.
Instead of saying
And over here
2.
you said divided by 2.5.
Yeah.
Yeah, if that helps you, write it. Now, did these reduce to the same fraction?
Yes.
So then these triangles are what? They are considered similar. The way you would write this officially, we have done this before, is you would say triangle JKL is similar to triangle MNP.
That's the school JKL.
No. We would be considered a joke.
That would be true.
Wait, what?
Just kidding.
If the acronym for our school was JKL. Just kidding, learning.
Just kidding, LOL.
Yeah. Right? I don't think anybody would take us seriously. Okay, we're gonna do this 2 more times. Grab your piece of paper.
They'd be like, we're putting JKL.
They'd be so confused. And then they'd be like, wait, was she serious? Or she, do I go? What do I do? Okay, so we have two triangles. They are already nicely facing the same way, so we're going to decide whether they are similar. So, you want to do the sideline first? Whichever one you put on top, it can be the smaller triangle on top or the bigger triangle on top. It doesn't matter. Fraction-wise, let's put this one on top. So I'm going to do 6 over what? Good. And reduce that, what do I get? One half, right? Okay, now I have to start with the same triangle. So which one did I put on top? So I need to put the 8 on top this time. Over, what's the bottom number? Somebody's whispering it over there. Good job, you have it right. Say it louder. Can I reduce that?
Yes, by 2.
By 8.
6.
By 8. 8 divided by 8 is 1. Wow, that shouldn't be an 8 on the bottom. I'm talking. 16 divided by 8 is?
2.
Did these end up being the same fraction?
Yes.
So these are considered similar. How would I write this?
Similar. JKL.
Look at the letters.
Similar triangle. RTS is similar to XZY.
Very good. Bless you.
That's confusing.
No, it's just the letters of the sentence.
It's just the letter of the triangles.
Yeah.
RTS.
Uh-huh.
Right.
See? She's trying to make a school name.
Yeah. Regular.
Got it?
Regular teacher school.
Okay, I'm moving on. Y'all are trying to similar. This guy? So, how did the ratios of each of these compare? What can you say about those two ratios, Anthony?
They're similar.
Which means they are? What's another way to say similar? Alike. What's another mathematical way you can say?
They're twins.
Really good way to say schools here. Okay, this is number 2. All right, so these are organized nice and neat for us. We just need to check their similarities. So which one do we want to put on the top of our fractions? The small triangle or the big triangle?
We're trying to do this.
It doesn't matter. Just pick one.
The big one.
Big one on top this time.
Boy.
So we're going to do 12 over what?
9.
Yep, because it's the similar corresponding spot. So reduce that. Divide both by 3.
Yeah.
So I get 4 over 3. Okay, so again I have to start with the big triangle. And I get 9 over what? 6. Which divide both by 3. So I'd get 3 over 2.
They are not similar.
Correct. Not similar. So that would be your answer. Okay, look at this. Which one? Huh? That's not a math. There. Another mathematical term would be
Equal.
3. This is just using your brain. How does the ratio of the leg lengths of a right triangle compare to the ratio of the corresponding leg lengths of a similar triangle? So let me go back. So you could say, in this case, the ratios are equal. Okay, remember, when you're looking at proportions of triangles that are similar, the ratios need to equal each other. So it needs to be the same ratio on both corresponding ratios. Make sense? Yep. I'm worried that when you eat, your brain turns off because you're enjoying the spiciness.
That's what my mom always says. Your energy from the brain goes to your stomach.
Well, we're hungry people. Whoa, spinning. All right, now let's put this into a graph.
Are humans the only ones that can get diabetes?
Say that again. Are humans?
Are humans the only ones that can get diabetes?
I believe as a,
No dogs can.
yeah, but is it called diabetes? Is this?
Diabetes.
I know everybody can deal with the same symptoms.
Even babies.
Oh yeah.
Facts.
All right, so this is example 2. Put this in your journals.
It's already time to go.
Yeah, because y'all kept asking me about life.
Why is it cool? Go by your own.
So for this one, you have to find similar right triangles using the points that you see on here. If you see here, we have this triangle and this triangle. So using those two, we're going to decide whether they are similar. So we're going to compare their legs. So for the first triangle, ABC, this one right here, you're going to compare the vertical leg to the horizontal leg. So vertical leg, horizontal leg. So that would be 2/3 for triangle ABC. So now let's look at triangle DEF. So again, vertical leg to horizontal leg, 4/6. Can I reduce that? Divide both by 2 and I get 2/3. This is for triangle DEF. So the ratio of the length of the vertical leg to the horizontal leg shows that they are similar. All right? We also need to find the ratio when you compare the two triangles to each other. You do this by comparing their slopes. So if you look here, we can look at rise over run. So if I have rise over run, let me use the other marker. Rise over run, I went up 2/3. Well, that's the ratio we have for each of these. That is also the slope. So the slope of both of these triangles is 2/3. So the slope of this particular line is 2/3. So these are two similar triangles. They have the same slope or the same ratio. All right, grab your paper. Let's do number 4. So we're looking at this graph. We see two triangles that show the rise and run of the line using points A and B and M and M. So A and B. So I'm going to go from A to B. And then the second one was M to N. So you have two triangles. They look similar, but let's double check. So we drew those two lines. You do need to graph this on your paper. So you can get a coordinate graph and draw this all in there, or you can sketch it. Either way is fine. So now we need to find the slope. So that was A, was to draw those in. For B, we need to find the slope. Well, the slope is rise over run. Well, my first one is going which direction? Negative. So it's a negative slope going down how many? 1, 2, 3, 4, 5, 6, 7, 8, 9. So we went down 10 over 1, 2, 3, 4, 5. So down 10 over 5, which reduces to down, how many times does 5 go into 10? -2. It's technically -2/1, but whenever you have it over 1, you can just leave it as the whole number. So my slope is -2. Now let's look at the second one. I went down 2 over 1. So again, my slope is -2. That's going to prove that these two right triangles are similar. Okay, you don't have to do C. So let's look at number 5. It says you draw a triangle that shows the slope of a line using 2 points. Then you draw another triangle that shows the slope of a different pair of points on the same line. Are the triangles similar? Well, yes, we just did that. So when you have 2 triangles that have the exact same slope, the ratios are going to always be the same. So you would say, yes, they are proportional. Which makes them similar triangles. And number 6, explain why you can't find the slope of a line using any 2 points on the line. Let me read that again. Explain why you can. I was like, yes, you can. Explain why you can find the slope of a line using any 2 points on the line. Well, this is why we didn't answer number 3 on the other one. Right triangles are drawn to show the slope of any 2 points on the line. So the short answer is any 2 points on a line would be similar. The slope would be anyway. Okay. That is it for the lesson. See you tomorrow.